Okay, good afternoon. So let me start the today's class. So the previous class, so we started with production of points. So we discussed how the points can be placed in any one of the four quadrants, how to draw the front view and top view, and including a side view we have discussed. And that point is, all of you know, point is a dimensionless object. So later, so I added the one-dimensional object, that is a straight line. The straight line also we have discussed. What do you mean by straight line? The shortest distance between any two given points is called the straight line. So in straight line, it's a one-dimensional object. We have discussed the only the first quadrant example we have discussed, that is first angle projection we have discussed, how to draw the front view, top view, true shape diagram, and how to analyze and how to note down the data, how to find out how to complete the projection and all. Now in this chapter I will be adding one more dimension to the object. That means one more dimension means, so we will discuss the two-dimensional object in this today's session. So that means the projection of plane surfaces. Either the plane is nothing but it's a perfectly a flat surface. Okay. Projection of planes is nothing but it is a two-dimensional object. It has got length and breadth, but even though it has got some thickness, we can neglect the thickness. For example, so if I take this mobile, so it is a two-dimensional object, you can say it's a rectangle in shape. It has got length and breadth, even though it has got some thickness, so we are neglecting the thickness in this case. So that means, so the planes in this planes of the chapter, we are going to discuss some important polygons. We'll discuss. And once again, I'll repeat this. A plane is a three-dimensional object, the two-dimensional object which has got only the length and breadth, even though it has got thickness. So we'll neglect the thickness for our projection purpose. And even a plane, simply a plane or a plane surface, plane lamina or a plate. So these are all the some of the common names that can be used for the same two-dimensional object. Once again, repeat, plane, I can call it as a plane surface, plane lamina I can call, or even simply a lamina, or even I can call it as a plate. Okay, all these terms will give you the same meaning. So as I told, here we're going to discuss some the standard regular the polygons we're going to discuss. Okay, so before going to the actual the exercises, so let me take up this the polygons. We'll discuss what are all polygons and then we'll go to the exercise. So these are all some of the polygons we're going to discuss in this chapter. Okay, so the first one is a triangle. The triangle has got the three sides. Triangle has got three sides, and this example which I have shown here, it is an equilateral triangle. It's a equilateral triangle. So equilateral, what do you mean by equilateral triangle? Wherein all the three sides are equal. Not only all the three sides are equal, all the angle, internal angle also equal. This and this and this. And for coming to the internal angle of the polygons, let me start from the triangle. The included angle of the internal angle of the triangle, it is 180 degree. The total angle of the any triangle, it might be here the equilateral triangle I have taken the example. So even right angle triangle or any isosceles triangle, even any irregular triangle if you take, the inside internal angle should be equal to 180 degrees. So for this equilateral triangle, so not only all the three sides are equal, this, even the three angles are also equal. So angles are equal in the sense how much you're going to get? Each angle 180 by 3. That means 60 degrees you're going to get. This is the equilateral triangular lamina. So the triangle, it has got three sides and three corners. So all the polygons, the same number of sides as well as same number of corners you're going to get. Okay, so how to draw the equilateral triangle? Next question arises. So how to draw the equilateral triangle? First you draw a line, vertical or horizontal line. just to draw a line which is equal to the side of the your triangle. For example, if I say draw a triangle of 30 millimeter, you draw a line which is equal to 30 millimeter. Okay. So in this equilateral triangle, all the three sides are equal, correct? So you take 30 millimeter with the help of your compass. So this is the center, you cut an arc, and this corner is the center, you cut and another arc. Wherever these two arcs meets, this intersection, you call it as one more corner. After getting this intersection, you join this corner to this intersection and this corner to this intersection. So now the equilateral triangle is ready. And after that, you can check the internal angles. It has to be 60 degree, and this has to be 60 degree, and this also has to be 60 degree. And one more method how to draw the equilateral triangle. After drawing a 30 millimeter line, whether vertical or horizontal line, which is equal to the side of the triangle. So now from here, you take your the protractor and draw a 60 degree line from here. From here, this angle should be 60 degree. Draw a 60 degree line from here, and as well as draw a 60 degree line from here. So wherever these two 60 degree line meets or intersect, okay, this is your one more the corner. After this, you can join it. So all the three corners you're going to get equilateral triangle. This is how the triangle has to be drawn. So next comes to the square. Square, what is a square? Wherein all the four sides are equal. Correct. And what about the included angle of the square? The total included internal angle of the your square is 360 degree. So that means 360 by all the four sides are equal in the sense for the square. Even the angles are also equal. 360 by 4, it is 90 degree. That means adjacent sides are perpendicular to each other in case of your square lamp. So how to draw a square? All of you know about it. Draw any one line which is equal to the side of your square. For example, if I say draw a square of 50 millimeter, you draw a line which is equal to 50 millimeter. Now after this, what you can do? Draw a vertical line, a perpendicular line from this end and from this end, which is equal to 50 millimeter again. After getting these 2 points, join it. Like this, you can draw the square. Similarly, coming to the rectangle. So how to draw? What is the difference between rectangle and square? Even rectangle, the included angle, internal included angle for the rectangle is also 360 degree only. And by 4 means here 90 degree you are going to get for all the corners here. The only difference between your square and rectangle, in square all the four sides are equal, correct? And whereas in rectangle opposite sides are equal. If I say draw a rectangle of side 40 millimeter by 20 millimeter. So the one parallel side is 40 millimeter, other perpendicular parallel side is 20 millimeter. So for example, 50 millimeter, the 40 millimeter, the longer side I have taken here. After this, you draw a two perpendicular lines from the end of this line. Now this line should be 20 millimeter. You take 20 millimeter length of this line, and these endpoints you can join it. Your rectangle is ready. Like this, you have to draw the rectangle. Next comes to your pentagon. So coming to the pentagon, so pentagon has got 5 sides and 5 corners, correct? So first we will discuss what is the total internal angle of the pentagon. The pentagon, the total internal angle of the pentagon is 540 degree. 540 degree. So how many the sides it has got? 5. That means for pentagon divided by 5. 540 divided by 5 means how much you are going to get? 108. Correct? That means this internal angle for the pentagon should be 108. All the angles are equal. Even pentagon, if I say it's a regular pentagon wherein all the sides are equal. In pentagon, we have 5 equal sides as well as 5 corners I am going to get. Now we'll discuss how to draw a pentagon. How to draw a pentagon. First I'll draw a line which is equal to the side of your pentagon, which is equal to side of your, for example, if I say draw a pentagon of 30 millimeter. I'll be drawing a line equal to 30 millimeter. After this, from this end as well as from this end, from both the ends, what I will do? So I'll take 108-degree internal angle, this angle, with the help of your protractor, and I'll draw a line, light line. On this 108-degree line on either side of your this 30 millimeter line, now you take 30 millimeter with the help of your compass. This as the center, you cut this, the 108-degree line. And here one more corner we will going to get. Similarly, from this point, you take 30 millimeter and cut it here, you will get one more corner. So 4 corners you will going to get now. Now after that, without changing the dimension of your compass, so this as the center, you cut an arc somewhere here, and from this as the center, you cut an arc. Wherever these two arcs intersect, you will get one more corner. Now all the 5 corners you can join it. Your pentagon is ready. So this how you have to draw the pentagon. Okay. Now coming to the hexagon. Hexa means 6. So hexagon means it has got 6 equal sides as well as 6 corners you are going to get. And coming to the internal angle, the included angle of the hexagon. So it is total included angle of the your internal angle of the hexagon is 720 degree. Okay, 720 divided by 6 means how much you're going to get? How much? So you're going to get, so 120 degree each. Okay, so 120 degree. So there are many methods are there where you can construct your pentagon as well as hexagon. The simple method to construct the hexagon is, first draw a circle. Draw a circle of the radius equal to the side of your hexagon. For example, if I say draw a hexagon of 30 millimeter. Okay, you take the 30 millimeter as your radius and draw a circle like this. Okay, after drawing a circle, from the center of the circle, you can draw a vertical line or horizontal line. Any, for this example which is shown here, you draw a vertical line, okay, passing through the center, and you should okay, end with the circle, circumference. Okay, so now after that you will get 2 points like this circle. Now without changing the radius of your that is radius 30 millimeter whatever you have taken with the help of your compass. So from this point you cut 30 millimeter on either side. So you'll be getting 2 more points. From this point you cut on either side of your circle with the same dimension. 2 more points. Total how many points you'll get? 1, 2, 3, 4, 5 and 6. After getting 6 corners, so you can join it with a thick line. Later you can remove the circle at the end. So this how you have to construct the hexagon. I hope all of you understood how to construct the triangle, square, rectangle as well as the pentagon, hexagon. The circle, how to construct the circle? So for example, you have to draw a circle of diameter 50 millimeter. How the diameter and radius are related? Diameter is twice the radius, correct? You take the radius of the circle 25 millimeter, draw a circle of 50 millimeter diameter, you can draw it like this. Okay, so this how the circle is drawn. So these are all the 6 the different types of polygons we'll going to discuss in this, the projection of planes chapter. And as I told, in all the polygons except your circle, we have a side or the edge as well as the corner, correct? As I told you, if so for example it's a rectangle, if I see 1, 2, 3, 4 edges I'll be getting, and 1, 2, 3, 4 corners I'll be getting. If it is a triangle, 1, 2, 3 corners I'll be getting, 1, 2, 3 the edges I'll be getting. Similarly for the pentagon, 5 edges and 5 corners. For hexagon, 5 edges and 6 edges, 6 corners you're going to get. But for your circular laminar circle, we won't get any corner or the edge. Okay, so infinite number of points you'll be getting at the circumference. So we don't have any edge condition or the corner condition for the your circular lamina. Now same polygons, so we will discuss. So what is the edge condition, what is the corner condition? Okay, next slide. Edge condition. Edge condition means if the the lamina or the plane surface is resting on one of its edges on HPRVP. So that is called as the edge condition. For example, so this is a rectangle. It is resting on edge means, so we have to rest it on the edge like this. It's a edge condition. If it is resting on corner means the corner we have to take and it has to be rest on the corner. So first let us discuss this edge condition. So edge in the sense, the irrespective of the type of the polygon is resting on edge either in HP or the VP, whatever the exercise he has given in the question. So here some of the shape of the polygon which I have taken here. So all are represents the edge condition only. So how? So for example, triangle, equilateral triangle. So here, so in all the cases in projection of plane surface, three different the views we have to write: initial position, second position, and third position. First position always we have to draw the true shape diagram or the true shape view. So for example, assume that the triangular lamina is resting on edge. You take that edge on your left side, even right side also you can take, just to maintain the uniformity. So the triangular lamina is resting on edge in the sense you take the edge on your left side 30 millimeters, for example 30 millimeter triangle, take it. Next 30 millimeter from here as well as from here, cut it. Your triangular lamina is ready with the corner condition. Similarly, square, draw a vertical line equal to 30 millimeter. Next from these 2 points draw perpendicular line and 90-degree line. Cut 30 millimeter from these two corners, you join it. Your square in the edge condition is ready. A rectangle edge condition, here the two possibilities we can have. Either the edges may resting on the smaller edge or the longer edge. Okay, here they have taken the example of the smaller edge. You can see, for example, 20 by 40. It is resting on the smaller edge. So you take vertical line. So always, how you have to practice the edge condition means while drawing the initial position, you take the edge left side of you. Okay, so you take 20 draw a vertical line and which is equal to 20 millimeter. Draw a 90-degree line from these 2 points, and the longer edge how much? 40 millimeter. 40 millimeter, cut it. From these two end points you join it, so your rectangle lamina is ready. For example, same example, the edge is the resting on longer edge. Then you take a vertical line which is equal to 40 millimeter. From these two ends you draw a 90-degree line, and this 90-degree perpendicular line you cut 20 millimeter. So like this, so you're going to get the longer edge. Similarly, coming to the pentagon, so edge condition, see to that the edge should come left side of you. Draw a vertical line which is equal to 30 millimeter. Okay. Now from this end you take internal angle 108 degree, from here 108 degree. Without changing this, with the help of your compass, cut 30 millimeter on this 108 degree. 4 points you will get. From this and this point you cut 30 millimeter. Wherever this intersects, you join this corner. Now all the corners you can join. Your pentagon, regular pentagon with the edge condition is ready. So like that. Coming to your hexagon, draw a circle which is equal to the radius which is equal to the side of your hexagon. Draw a circle, and for edge condition, as I told, from the center you draw a vertical line. Assume that you have a circle here. From the center, passing through the center, you draw a vertical line. From this point you cut on either side 30 millimeter. From this point you cut on either side of your circle 30 millimeter. So 6 points will get, join it at the end. So the edges you are getting it at the left side of you. So like this edge conditions were drawn. Similarly, once again we will discuss these the shapes for the corner condition. Similarly, the edge condition means we have taken the edge towards left side of us. Similarly, for the corner condition, so and so polygon plane surface is resting on one of its corners. On HPRVP, we will discuss that in detail. You take that corner left side of you and then draw the true shape diagram. How to draw it? The corner should come left side of you, correct? So you draw one vertical line, triangle I am showing, which is equal to 30 millimeter, the side of the triangle. From here you draw arc which is equal to 30 millimeter. From this point you draw an arc which is equal to 30 millimeter. The intersection point will get one more corner. Now you can join this. You're going to get a triangle lamina with its corner condition. That means corner you should draw left side. That's all. Now coming to the square, how to draw the square corner condition? First, you draw one horizontal line. You draw one horizontal line first. So on the horizontal line, you take any one of the point. You take any one of the point of the horizontal line, and from that point, you draw 45-degree line above horizontal line and 45-degree line below horizontal line. Draw 45-degree lines on both the sides. That is above the horizontal line as well as the below the horizontal line. After that, so you take 30 millimeter, the side of the your square. From this point which you have identified, you cut 30 millimeter on this 45-degree line, as well as from the same point you cut it on this 45-degree line. So how many points will get? 1, 2, 3 points will get. After this, from this as the center, you cut 30 millimeter arc. From this as the center, cut 30 millimeter arc. Wherever it intersect, one more corner you will going to get. Now you join all the 4 corners, you will going to get a square in the corner condition. Like this, you have to draw the square. Then the rectangle corner condition we won't discuss. The same way we have to draw this the corner condition rectangle. For example, you have drawn the draw a horizontal line. Take any one of the point on that, draw 45-degree line on either side. 40-20 if it is given the rectangular lamina side 40 millimeter by 20 millimeter. From this point, you take 20 millimeter, cut it on the 45-degree line. Same point, you take 40 millimeter and cut it on this 45-degree line. Now, because in rectangle opposite sides should be equal, correct? From here, you take this 20 millimeter and cut an arc. From this point, you take 40 millimeter cut an arc. Wherever it intersects, you join all the 4 corners, you're going to get a rectangle in the corner condition. Similarly, pentagon, how to draw a pentagon? The corner condition, same thing. Draw a vertical line which is equal to the side of the pentagon, that is 30 millimeter. Draw 108-degree from both the ends of this line, internal angle 108-degree, 108-degree. Now, on this 108-degree from here, you cut 30 millimeter, from here, you cut 30 millimeter. You're going to get 4 points. Now, from here, you cut a 30 millimeter arc, from here, cut a 30 millimeter arc. Wherever it intersects, okay, you're going to get one more corner. You can join all the 5 corners, you're going to get the pentagon in the corner condition. Okay. Now coming to the hexagon in the corner condition. Now what you have to do, from the center, you take any one point of the center, and the hexagon size, assume that it is 30 millimeter. So you take the radius of the circle which is equal to the your hexagon side. From you take 30 millimeter as the radius, draw a circle like this. Okay. After drawing a circle, passing through from the center, you draw a horizontal line for the corner condition like this. Draw a horizontal line passing through the corner. So you'll get 2 points here. Now from this point, without changing 30 millimeter, cut it on either side of the circle. From here, cut it on the either side of the circle. 6 points you'll get. And then you join all the 6 points, you're going to get this hexagon in the corner condition. That's all. So like this. So what and all we have discussed till now. So what is a plane? That's a 2-dimensional object. And we discussed different types of polygons like triangle, square, rectangle, pentagon, hexagon, and circular lamina. And we discussed the different conditions like edge condition as well as the corner condition. How to draw the initial position, a true shape diagram when the plane surface is resting on corner or the resting on edge. So these things are very important. Now we'll discuss the example. And here also let me clarify. For here also the inclination with respect to HP, it is called theta, that is true inclination. The inclination with respect to VP, it is called phi, same thing, the true inclination. The apparent inclination with respect to HP, it is alpha. Similarly, the apparent inclination with respect to VP, it is beta, like this. So with this, this is the only basics which is required. Okay. To complete the orthographic projection of the plane surface. So let me take up the first example. Today we'll take the triangular lamina, the 2 cases. In all the polygons, I will be discussing two cases. One is the edge condition and another one is the corner condition. Okay, let me take the edge condition now. So what is the question is given? An equilateral triangle lamina of 25 mm side lies with one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. Draw the projections. So these are all the data he has given. So let me start from the beginning. Let me start from the beginning and understand. Okay, how to, as I told, in this projection of plane surface, three different the positions I have to draw. First position, I need to draw the true shape diagram. Where it is resting, I have to place the lamina over there and I need to draw the true shape diagram. Second position, I need to take the first inclination, I need to complete the projection. Third position, I need to take the another inclination and I need to complete it. And some of the clues which I'm going to give here before starting, the lamina is resting on HP. The lamina is resting on HP, whether it is resting on the corner or edge, that is secondary. On HP in the sense, the true shape diagram has to be written on HP means in the top view only. Similarly, if the lamina is resting on VP, that is resting on corner or edge, that is secondary. So then the front view, you should write the true shape diagram. That is on VP, we should draw the true shape diagram like this. So let me start here, an equilateral triangle lamina. So the object given here, it is an equilateral triangle wherein all the three sides are equal of 25 mm side. That means the equilateral triangle lamina size is 25 mm. Lies with one of its edges on HP. He says the equilateral lamina is resting on one of its edges on HP. It has got three edges. It may rest on any one of the edges on VP such that the surface of the lamina is inclined to HP at 60 degrees. This is the second position. The edge on which it rests, it is inclined to VP at 30 degree. Draw the, this is the third position. Let me start with the true shape diagram. He says, assume that this is your triangular lamina. So assume that this is the equilateral triangular lamina. He says the equilateral triangular lamina at 25 mm. It is resting on one of his side on HP. Okay, it is resting on one of his side. You keep the entire lamina on HP. You keep the entire lamina on HP and if you see from the top, it look like a equilateral triangle such that the edge should come left side of you. Like that, you draw the true shape diagram. So how to draw that? So always it's a first angle projection system we are doing. So draw the XY line first. Write your VP and HP position properly. And since it is resting on one of its edges on HP, that means so it is placed on HP like this. That's why the top view I can see the true shape diagram of this triangle. So that's why what you can do is edge condition, it is resting on edge. You draw a vertical line which is equal to 25 mm, and from this end you cut 25 mm here, and from this end you cut 25 mm. So wherever it intersects, you will get one more point. Just for my convenient, I can name this corner with my own names. Here I have given ABC. You can take any name. You can take A, B, C. Three corners I have named it and I have dimensioned it. So this particular the side is 25 mm. All the sides are 25 mm because it is equilateral triangle. To do this, so this is the true shape diagram. Top view is completed. Now we have to write the front view for this. So the lamina is resting on one of its edges on HP like this. So I have kept it like this. Why I am keeping it like this? I am making it parallel to HP so that I can see the true shape of your lamina. Same thing in the projection of straight lines also we are doing it. Correct? So here this is the actual position. Actually, I am placing the entire lamina like this on HP so that I can see the shape of the triangle in the, that is done. Now if you see from the front side, so if you see from the front side, it look like a straight line. Correct? So that's why. So how to draw a front view for this? Draw a vertical projectors from this, from all the corners. Like this, you can draw a vertical projector till it meets the XY line. So like this. Okay. So now how to identify the points here? So you're looking from here, front view. C and B I can see, I cannot see the point A. Correct? So that means in general, how to represent the corner that we cannot see that point. So we have to mention that within the bracket, that particular point. That is an indication that that particular point we cannot see from that particular view. So you're looking from here, C I can see, the B I can see, but I cannot see A. So that's why B dash, C dash within the bracket, A dash I have to write it. Now after drawing vertical projector, so join these two points, so you're going to get a thick line. So this is nothing but your front view. Once again, let me show you here. The lamina is resting on edge as given. I kept the entire lamina, triangle lamina from the top view so that I can draw the true shape diagram. Equilateral triangle I can see. In the front view it look like a line. So that's what it is. It's a line view. Okay, it's perpendicular because it's perpendicular to VP. That's why a line view I can see. Okay, so this is your front view. So this is called as the first position. In all the polygons, whatever the procedure I am giving now, same procedure is followed. This is the first, the position is completed. Now the second position, will go for the second position. So what the question says, the lamina, the surface of the lamina is inclined at the 30 degree, 60 degree to HP, he says 60 degree to HP. Surface of the lamina means this one. So this is the surface. This particular surface of the lamina is inclined at 60 degree to HP as given. Always one more hint let me give you. If the lamina is resting on HP, second position HP inclination only you should consider. Third position you should consider the VP inclination. Similarly, if the lamina is resting on VP, second position we have to consider the VP inclination first. Next, the final position you have to consider the HP inclination. So for this second position, how to draw it? So after the first position, the same XY line, you take any one of the point on the XY line and draw a 60 degree line right side of you like this. Okay, you draw a 60 degree line like this. From any point you can take and draw a 60 degree line like this. Now, so any point you have taken, so I'll be taking this point as the C dash and within the bracket A dash. Now what I exactly have to do is, this is the front view. I have to tilt it such that it is making an angle of 60 degree. That's all. Got it? So this angle I have taken 60 degree. This angle I have taken, I need to shift this. That means without changing the length of this previous front view, you take this length with the help of your compass. Now this as the center, this as the radius, this as the center, you cut 60 degree line. So wherever it cuts, so you call that particular point as the B dash. So what you have done here, without changing its length of the front view, so you have to shift it on the 60 degree line. This is what you have to do. This is the second position front view. Now after this, to get the top view, what you have to do, keep on draw the vertical projectors from the previous the front view, and keep on draw the horizontal projectors like this from the previous top view like this. After this, you coincide the points. For example, A is here, horizontal projector of A dash is here. This is A. B is here and B dash is here. This is B. C is here and C dash is here. This is C. So all the points you're going to get. Now you join these three points A, B, C. So you're going to get one more triangle, which is not the equilateral triangle. You will going to get this triangle. So reduced shape of the the true shape diagram, which is called as the apparent shape of your triangular lamina or triangle. So this is apparent shape of this the triangular lamina. So this completes your top view. That means till here the second position is completed. Okay. So the third position, what you say is, the edge of the lamina which is resting on HP, so makes an angle 60 degree with respect to VP, says 60 degree with respect to VP, says. So what you have to do? So right side you take any one point, either 60 degree you can draw it like this, or you can draw it like this also. Okay, in 4 different ways you can do it. Okay, see, this is the second position. Third position 60 degree. Now it is perpendicular to VP. Correct? Perpendicular to VP. So he says the VP inclination 60. Either I can tilt the lamina in this fashion which I have taken there, or else I can tilt it in this way also. Okay, that's why for the third position, So you can take any one point again, and you can take that inclination in any direction. Either the way which I have taken like this 60 degree, or else you can take on the other side also 60 degree like this. The only thing is how easily you can shift this triangle. That is very, very important. So what exactly you have to do it after drawing the 60 degree? So you have to redraw this apparent shape of the triangle such that the resting edge AC should come on the 60 degree line. That's all. That is the only thing that you have to do it. So after drawing 60 degree, I'll take any one of the point on this 60 degree line. I'll call this as the A. I'll take this A to C distance, and A as the center. I'll cut this at 60 degree line. Wherever it cuts, I'll call that as the C point. After getting AC point, A to B distance and C to B distance should be same. Okay. To take the distance, A as the center, you cut an arc. C as the distance, you cut an arc. Wherever these two arcs intersect, so that point you can call it as the point B. Now you can join this A, B, C. So this completes the third position top view. That means what exactly you have done? You have not done anything. Without changing its shape and size, you have redrawn this apparent shape of the triangle such that the resting edge, that is AC, should come on this 60 degree line. This is exactly how we have done. So this triangle, you have tilted it like this. That's all. So for this top view, I have written. The front view I should write by looking from this direction. How to do it? For the final front view, you keep on draw the vertical projector from all the points of your top view like this, 3 points A, B, C. Similarly, draw the horizontal projectors from all the points. Now you coincide the points. How to do it? Point A comes like this, and point A dash like this is A dash. B, this is B dash, this is B dash. Point C, C dash, this is C, this point is C dash. Now after getting this, all the 3 points, you join this with a thick line. So the apparent shape of the front view is also ready like this. In 3 different positions, I need to draw it. The same procedure holds good, or we have to follow for the projection of planes which is given to you. First, initial position we have to write, whether it is resting on HP or VP or corner or edge. We have to read it carefully, and we need to draw the true shape diagram. Next, first inclination I have to take, second position, and finally third position I need to take another inclination. Like this, I need to complete the projection of the triangular lamina. Next, this is the edge condition. One more example I will be taking today. So the corner condition also we are going to discuss. What is that? Let me take this example. A triangular lamina of 25 millimeter sides rests on one of its corners on VP such that the median passing through the corner on which it rests is inclined at 30 degree to HP and 45 degree to VP. Draw its projections. See as given. So here, let me read it once again. A triangular lamina of 25 millimeter sides. Okay. Either if it gives equilateral triangle or a triangular lamina of 25 millimeter, it gives the same meaning. Okay. That means always the regular polygon, in the sense all the sides are equal. So you have to consider the 25 millimeter side of the triangular lamina, equilateral triangular lamina, rests on one of its corners on HP. It is resting on corner. Immediately should come to your mind that I should write the corner left side. Then resting on HP, it's not resting on HP, it is resting on VP. So resting on VP in the sense, so front view I should write the true shape diagram. Where is VP? First you draw the XY line, fix your HP and VP position like this. After that, so this is your VP. Here I should draw the front view because he says one of his corner is resting on VP, correct? So I'll draw one vertical line which is equal to 25 millimeter. Now with this corner I'll cut this 25 millimeter, with this corner I'll cut 25 millimeter. I'll get 3 corners, so I'll be joining it. So my true shape diagram of the triangular lamina is ready in the front view. You can name it any name. I've given A dash, B dash and C dash. Okay. And one more construction work I have done in the true shape diagram. Why means, in the second sentence he says the median passing through the corner on which it rests is inclined at 30 degree to HP. So the median are perpendicular bisector, one and the same. Okay. The median in the sense, so this is the corner where it is resting. Median passing through the corner in the sense, so I have to draw a line such that, okay, I have to draw a line from the corner such that, so this line joins this, the opposite edge, that is C dash and B dash, exactly at the center, at the midpoint. So this line is called as the median. Okay, that means how to do that? You draw a horizontal line from this A dash corner. So wherever it meets the B dash and C dash edge, so you call that as the one more point just for the construction work. So that is D1 dash is my the median, that is A dash, and D1 dash is my median line which is passing through the corner. Okay, so this is the construction work I have done. So I have completed the true shape diagram in the front view. Now how to draw the top view? So you keep on draw the vertical projector from all the points, and then till it meets the XY line. So, and here also you are looking from the top side. A point you can see, B point you can see, you cannot see the C point. It is exactly like this. That's why A and B I can write without the bracket. C I cannot see. That's why we should write within the bracket. Next you join this. So this is your front. It is exact. So this is a triangular lamina. It's resting on VP. So resting on VP means, so I have kept the lamina and VP so that I can see in the front view, I can see corner condition, right? Okay. Triangle. Next, the top view, it look like a straight line. Okay, where this and this corner you can see, you cannot see this corner. So the first position is completed, true shape diagram as well as the top view is completed. Coming to the second position, he says the median passing through the corner, A dash and D dash. Okay, it is inclined at 45 degree to VP, he says. He says it is inclined at 45 degree to VP. You take any one of the point on the XY line, right side, draw a 45 degree line, right side like this. After drawing a 45 degree line, you call this point as the A. Now you take this distance, front view length as the distance, this as the center, you cut 45 degree line like this. Okay, cut this, call this point as the B and C. That means you have to redraw this top view such that this top view should come on this 45 degree line. So this completes your the second position top view. Now coming to the front view, you keep on draw the vertical projectors from all the points like this, and draw the horizontal projectors from all the previous top view and as well as front view. Now coincide the points. A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. And C is here, C dash is here, this is C dash. Join it, you're going to get the apparent shape of your triangular lamina, you're going to get. And similarly, so this line, this line you extend it, you call it as the D2 dash, because this this A1, A dash, D1 dash is not equal to A dash and D2 dash. So just here also the construction line you draw it, that is the median passing through the corner. The length will be apparent length. A dash, D1 dash is the true length of the median. A dash, D2 dash is the apparent length of the median. For the third, the position what he has given, same median is inclined at the 30 degree to HP. He says 30 degree to HP. He says, so that means, so the inclination whatever he has given, it is a true inclination. Okay, but here the median, so where I am inclining, it is not the true length, it is the apparent length. So this medium and this median is not equal. This shape and this shape is not equal. What I have to do is, first you take right side any one of the point and draw the 30 degree line HP. Okay, now on this 30 degree line you take any one of the point and call that as the corner A dash. It is resting on corner. Okay, so after this, now you take the true length of the your median A dash D1 dash, cut it on the 30 degree line. Wherever it cuts the 30 degree line, you call that as a D1 dash and draw the horizontal projector line passing through this point. You call that as the locus line. You call this as the locus line. So after this, now you take the apparent length of the your median from the previous top view. Okay, So A dash and D2 dash length, you take A dash, you cut that A dash D2 dash length on the locus line or the horizontal line. Wherever it cuts, you call that as the D2 dash. Okay, so now you join this line, that is the A1 dash, A dash and D2 dash with a light line. So, and extend this angle, extend this D2 dash A dash till it meets the XY line. So this is nothing but your apparent inclination with respect to HP, that is alpha. You have to find it out at the end. So now what you have to do, you have to redraw this previous front view such that A dash and D2 dash should exactly coincide with this A dash and D2 dash. Okay, so like this you have to redraw it. So after getting this A dash and D2 here, how to draw a line? So from here, what you can do, from D2 dash, this line is there now. From this line you draw a perpendicular line, 90-degree line, because this median line bisects this line. So this is 90-degree as well as this is also 90-degree. So for this line you take perpendicular line, draw a line on both the side. Now from D2 dash to B dash and D2 dash to C dash distance is same. Take with the help of your compass, this as the center, you cut that distance, this as the center, you cut this on either side. Then you can call this as the B dash and C dash. Join this without changing its position and its size. So this is what you have done here. So without doing anything, without changing anything, so you have to redraw this apparent shape of the triangle from here to here exactly, and this, so this completes your the third position front view. Now the top view, it's very easy. Draw the vertical projector from all the points of the previous front view and draw the horizontal projectors like this from the previous top view. Coincide the points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here and C dash is here, this is C. Now after getting these 3 points, join it. So this is the actual, the top view, whatever you will going to get. It is like this. First you have taken, then you have tilted like this, and then afterwards you have tilted it this way. So like this. So you have to complete the projection. So with this, the triangular lamina, both the corner condition as well as the edge condition, we have completed for this class. So any doubts or any clarification on this, so you can feel free to put it in